Minasan, konnichiwa. Zamurai Engineer desu. In this video, let us continue discussion on Gaussian method in solving simultaneous linear equations. So, in this video, we'll have another example. Our example number 2 that will use our learned modification, which is Gauss elimination with pivoting. So with partial pivoting. Example 2, solve the following set of equations by Gaussian elimination with partial pivoting. So we have 3 equations, 3 unknowns. So it is the same as one of our example wherein we are solving the coefficient A1, A2, A3. We are solving the equation, but in this problem, this is A1, A2, A3 are the variables. Okay, variables. Okay. So let us start with forward elimination. Then after which we're going to do the backward substitution. To simplify the writing of the problem, we are actually implementing the extended matrix format. Number of steps of forward elimination, that is n minus 1, so n is 3, therefore there are 2 steps for forward elimination. Step 1, examine absolute values of first column. Okay, this is our partial pivoting. Examine first column. Okay, the first column is 25, 64, and 144. Here, 25, 64, and 144. This is the first column. The largest absolute value is 144 and exists in row 3. Therefore, we have to switch row 1 and row 3. Okay. We are looking at the largest absolute value. So that is our way of dealing with these things to avoid the 2 pitfalls. Okay. Switch. So now we are switched with equation 1 being now the equation number 3. Okay. So let us do the forward elimination. First step of operation. So this first equation, divide by 144, multiply by 64. And the answer would be 0.44444. Okay. So then the first equation multiplied by that will have what? 63.99, which is actually our target is for that to be equal to 64. Okay, so there is a small error. There's already a small error there. So if we make it, we are using what? 4 significant digits. 1, 2, 3, 4. If we use 6 significant digits, it is more likely to be equal to 64 rather than 63.499. So if we subtract this one, the answer is not 0 but 0.01. And we just assume that it is 0 and then do the process. Okay? But because we are sure that this is just a matter of what? Of rounding of error. It's just a rounding of error. That's why we come up to this equation. This is now our updated equation number 2. So put it on the place for equation number 2 here. Okay. That is what? 0, 2.67, and then 0.5556. So we are using what? 4 significant digits. Okay. So 53.10, this is 4 significant digits. Okay. So we have now the updated matrix of our problem. Okay, let's go on for the next one. Let's do that again. Divide again by 144 now, multiply by 25 because we would like to eliminate the first coefficient, first term coefficient of the third equation. So by doing that, 25 divided by 144, That is 0.1736. This is for significant digits. Using that, 0.1736 multiply all throughout equation 1. Equation 1 will become like this. Okay? And because of that, let us take note. The first term is 25. Subtract it to the third equation. Third equation is what? 25, 5, 1, and 106.8, as you can see here. So subtract our manipulated equation from equation 1 to the equation 3, and we will have 0, 2.917, 0.8264, 58.33. We are using 4 significant digits. Okay, and therefore this is our now the updated equation number 3, and put that on our matrix. So this is now our updated matrix form. Okay, so you will notice we are able to do the first step, which is what? Making the first term coefficient of other equation to be 0. Now let us look at this. We would like this to be 0 also, and therefore examine the absolute values of the. We are looking at absolute values. Take note of our technique, that is partial pivoting. So absolute values of this one. Compare the absolute values. Which one is greater? The largest absolute value is 2.917 and exists in row 3. Therefore, we have to switch again equation 3 and equation 2. Switch it. Switch the 2. So by switching, we are able to. So let us compare the absolute value and the switch before we do the forward elimination. Very easy to do. Now let us use equation 2, manipulate equation 2 in order to subtract it to equation 3, and we'll make equation 3 second coefficient to be 0. Let's do that. So manipulate equation 2 by dividing this equation by 2.917. The answer will be 1, and then multiply by 2.667. So the answer would be 2.67 divided by 2.917, that is 0.9143, 4 significant digit. And that is to be multiplied to the second equation. Right? Multiply this to the second equation, it will become 0, 2.67, 0.7556, and 53.33. So this is our manipulated equation number 2. And let us subtract this to equation number 3, which is 0, 2.67, 0.5556, and 5310. This is our equation 3. Subtract our manipulated equation 2, and then we'll get 0, 0, negative 0.2, negative 0.23. And therefore, this is our updated equation 3. Replace our previous equation 3 by that updated one. So we have this following updated matrix, wherein you can you can say that we already able to produce the upper triangular matrix that we desire for this type of method. Okay, and therefore after producing the upper triangular matrix, it's now time for back substitution, because we already know we can easily find out the value of A3 here. So A3 is just what? Negative 0.2, A3 is equal to negative 0.23. So therefore, divide both sides by 0.2, negative 0.23 divided by 0.2, that is 1.15. That is the value of A3. Since we already know the value of A3, substitute it here. This is the coefficient of A3, so A3 times this one, we can solve the value of A2. Okay, so let's do that. So multiply A3 to that, this one, A3 to that value, and then manipulate the algebra. Just do the algebra, and we are going to solve for A2, which is equal to 19.67. We are doing 4 significant digits. Okay. Then lastly, since we already know two values, A2 and A3, we can solve for A1. So solving for A1, this is 144, A1, 12, A2, and A3 is equal to 279.2. 279.2. This is our last remaining equation for the box substitution. So transfer these two to the other side because we already know those values A2 and A3. Okay. So transfer, they will become negative, okay, and then divide all of the sides by 144, and then evaluate. So 279.2 negative 12 times A2, negative 12 times 19.67 minus A3, which is minus 1.15, and divided by 144 should be equal to 0.2917. So we already know all of the values A1, A2, and A3. What are those? So in summary, the values are here using matrix format. Okay, so A1 is equal to this, A2 is equal to this, A3 is equal to this. Okay, it's very easy. Okay, so is your answer equal to this answer? Okay, so this is our Gaussian elimination with partial pivoting solution. Partial pivoting, we are comparing the magnitude of the absolute value of the row that we are going to use. Okay, so that we'll have what? So that we will have partial pivoting and overcome the pitfalls of rounding of errors and division by 0. Okay, so this should be it. Again, please watch, review, and try to do the previous 4 different tasks of practice and use the pivoting, partial pivoting solution and compare the result and compare how it is able to counteract the potential problem of the 2 pitfalls. Again, this is Dr. EYPEI, preaching engineering for nation building.